The disk extent allocator is a subsystem responsible for managing contiguous blocks of storage on the underlying persistent medium. Extents represent logical ranges of consecutive sectors allocated to logical volumes or object containers. The allocator maintains internal metadata structures, tracking free and occupied extents with allocation decisions, governed by a fragmentation-aware policy that attempts to minimize scatter and consolidation overhead during later compaction phases. Extent allocation operates through a configurable strategy parameter specified at allocator initialization. The first fit strategy examines the free extent list in sequential order and selects the first range sufficiently large for the requested block count. Best fit performs full enumeration and selects the extent minimizing waste. Worst fit targets the largest available extent to defer fragmentation. The default strategy is first fit with a minimum extent size of 16 kilobytes. The internal free extent list is maintained as a sorted link data structure ordered by sector offset. Insertion of newly freed extents performs automatic coalescing with adjacent free ranges. When a freed extent shares a boundary with an existing free extent, the two ranges merge into a single entry. This coalescing reduces metadata overhead and improves allocation locality in subsequent operations. Merging occurs without triggering a checkpoint or log flush. Extent allocation requests are submitted through the Allocate Extent interface, which accepts a block count parameter and an optional locality hint. The locality hint specifies a preferred starting sector, allowing the allocator to favor allocations near previously accessed regions. If no hint is provided or the hinted region lacks sufficient contiguous space, the allocator falls back to the configured strategy. The returned extent structure contains the starting sector offset and the allocated block count. The allocator maintains a secondary data structure called the extent bitmap, which tracks allocation state at a granularity of 1 bit per allocation unit. The default allocation unit size is 4 kilobytes, yielding 1 bitmap byte per 32 kilobytes of storage. This bitmap provides O1 membership testing for range queries and enables efficient bulk status operations. The bitmap is rebuilt during allocator initialization from the persistent extent metadata. Deallocation of extents occurs through the deallocate extent interface, which accepts an extent reference. The deallocate operation marks the extent as free and schedules the range for coalescing on the next maintenance interval. A deferred coalescing approach reduces latency for deallocation calls. If immediate coalescing is required, the force coalesce method triggers synchronous merging of adjacent free ranges. Force coalescing may incur observable latency and should be invoked sparingly. Fragmentation monitoring is exposed through the fragmentation ratio query method, which returns the ratio of occupied extents to total extents. A low fragmentation ratio indicates the free space is consolidated in few large ranges. A high ratio suggests scattered allocation leading to suboptimal allocation performance. The recommended threshold for triggering offline defragmentation is a fragmentation ratio exceeding 0.6, although this threshold is configurable. The extent allocator implements a low watermark allocation avoidance feature. When free space falls below the low watermark threshold, the allocator returns an allocation error rather than proceeding. The default low watermark is 5% of total storage capacity. This mechanism prevents the system from entering a state where allocation requests consistently fail due to fragmentation. The threshold is tunable through the config.extentAllocator.low watermark parameter. Allocation statistics are continuously accumulated in the allocator's metrics register. These statistics include total allocations performed, deallocations processed, successful coalescing events, and allocation failures due to insufficient space. The metrics register is queryable through the getMetrics interface without requiring a checkpoint operation. Statistics are reset through the resetMetrics call, which takes effect immediately. Statistics do not persist across allocator restarts unless explicitly logged. The extent allocator supports configuration of a maximum fragment size parameter. When fragmentation reaches levels where no single free extent exceeds the maximum fragment size threshold, the allocator raises an allocation fragments too small event. This event serves as an early warning for system operators that defragmentation is necessary. The maximum fragment size is expressed in kilobytes and defaults to 1 megabyte. Setting this parameter to 0 disables the warning mechanism. Extent validation occurs on allocator startup through the validate extents method. This method performs consistency checks on the persistent extent metadata and rebuilds internal structures if inconsistencies are detected. The validation process scans all extent records and verifies no overlapping allocations exist. If overlaps are detected and auto-repair mode is enabled, the allocator attempts to resolve conflicts by adjusting extent boundaries. Auto-repair mode is disabled by default. Extent pre-allocation is supported through the pre-allocate extent range method, which reserves a contiguous range of extents for future allocation. Pre-allocation helps applications avoid allocation latency when burst request patterns are anticipated. Pre-allocated extents are held in a reserved pool and are consumed by standard allocation requests before examining the main free list. Excessive pre-allocation may reduce overall system allocation flexibility and should be applied judiciously. The allocator exposes an extent locality hint prediction feature through the predict best locality method. Given a size requirement, this method examines historical allocation patterns and returns a sector offset likely to optimize future access patterns. The prediction mechanism analyzes recent allocation and deallocation sequences to identify thermally favorable regions. Predictions are probabilistic and should not be treated as guarantees. Predictions expire after 30 seconds and require refresh. Defragmentation scheduling is managed through the defragmentation strategy configuration parameter. The inline strategy performs opportunistic defragmentation during normal operation, consolidating extents when system load is low. The scheduled strategy initiates defragmentation at predefined intervals configured through the defragmentation interval seconds parameter. The manual strategy requires explicit invocation through the trigger defragmentation method. Scheduled defragmentation defaults to once per 6 hours. The extent allocator maintains a transaction log of allocation and deallocation events for crash recovery purposes. The log is buffered in memory and persisted to stable storage at checkpoint boundaries. For high-frequency allocation workloads, the log may be batched to reduce write volume. The log batch count parameter controls the number of operations buffered before forced persistence. The default batch count is 1000 operations. Shutdown of the extent allocator is triggered through the shutdown method, which performs final validation and persists all pending metadata to stable storage. During shutdown, any pre-allocated extents are released and reintegrated into the free list. The shutdown process is synchronous and blocks until all I/O operations have completed. After shutdown completes, the allocator instance becomes unusable and a new instance must be created for subsequent operations.